Good morning, everyone. So, our today's lead code problem is arithmetic slices to subsequence. We have given an integer array nums. We have to return the number of all arithmetic subsequences of nums. First of all, what is arithmetic subsequences? A sequence of numbers is called arithmetic if it consists of at least three elements and if the difference between any two consecutive elements is the same. So, our two conditions are the arithmetic subsequence should be considered of at least three elements, and difference between any two consecutive elements in that subsequence should be same. That is our arithmetic subsequence. Like for example, in this 1 3 5 7 9 is a arithmetic sequence because 3 minus 1 2 common difference is 2 between n and size greater than 3. Now, first of all, we will try to understand the question. What exactly this question is asking us. We are given this array 2, 4, 6, 8, 10. Now we have to count the number of all our arithmetic subsequent slices which can be made by this. Now we have to count such subsequences whose size is greater than or equal to 3 and the common difference between them will be same. So there will be 2, 4, 6 because their common difference is 2. 2, 4, 6, 8 again common difference 2. 2, 4, 6, 8, 10 again common difference 2. These are 3. 2, 4, 6, 2, 4, 6, 8 and 2, 4, 6, 8, 10. Now starting from 4. 4, 6, 8, 4, 6, 8, 10. 2. 4, 6, 8 and 4, 6, 8, 10. Now starting from 6. 6, 8, 10 and yes, only 6, 8, 10. Now, now other can be 2, 6, 10. Common difference is 4. 2, 6, 10. Thus we get these 7 arithmetic slices subsequence from this question. Now first of all we will have to build the intuition. What can we do? If we observe that if we know the subsequences formed by these 2, 4, 6, then if we take this into account 8, then we also can know the total subsequences formed by using this 8 by knowing this past 12. So this question is pointing our intuition towards TP. So now we will understand how can we approach this question. So I have prepared something to show you. Now this is our given array. These are our indexes. Now if we have to use first of all I and j both are at this index. So I equals to 0 and j equals to 0. Now we have to count the subsequences ending at I in which common difference which are satisfying this conditions of common difference. Now, but I equals to 0 and j equals to 0 will not satisfy condition, so we'll move I ahead and again start with j equals to 0. Now I is at 1 and j equals to 0. Now our common difference is 4 minus 2, 2. So now we have one subsequence with two common difference, that is 2 comma 4. Now again, if we further move I and count the further move I, now we have to count 6 minus 2, 4. Now we have one subsequence with a common difference of 4, that is 2 comma 6. Now if we again do that at 2, now we have 6 minus 4, 2. 2 common difference ending with j. But at this j, we have already have this one subsequence. Now, this means we can add this number to that subsequence will also result in our arithmetic subsequence. That's why we have to increase the counter by 1. So it will become 2. 4, 6 we get by this. And after adding 6 to this subsequence, we get 2, 4, 6. In more detail, we can do this. Now, we have I equals to 1 and we are checking at j equals to 0. Now, common difference is 2. Number of subsequences we are getting is 2 comma 4 1 only. These are all the cases. We can form the subsequence ending with I and common difference 2. Now we increase the I counter by 1. Now I will come here and now again j will come at 0. Now 6 minus 2 4. Common difference 4. One subsequence we are getting 2 comma 6. Now we will increase the j counter. Common difference 2. One subsequence we are getting 2. But at this common difference, at the previous j we have already got this common difference too. This means we can add the I to this subsequence. So we have formed 2 comma 4 comma 6 and 4 comma 6. Now we again move the counter I by 1 and again start with j equals to 0. Now 8 minus 2 6. Common difference 6. One subsequence we are getting 2 comma 8. Similarly, we again move forward the counter j. Common difference 8 minus 4 equals to 4 and frequency 1. The subsequence is 4 comma 8. We have not previously encountered any the common difference 4. Okay. Now we have encountered previously, that's why we have previously increased this count by 1. Now common difference 2 frequency is 3 because we have already got the common difference 2 ending at this j 6. Now we can add 8 to both of these and we will get our new subsequence. That's why we have increased our counter by 2, which were previously 1, because we have got these 2 also and increased this count. So we have got these 2 subsequence with common difference 2. Similarly, we can move forward I and calculate for this. Now, therefore, this at this case with common difference 4 and 2. At this j, ending at this j, we have already got one subsequence with common difference 4. That is 2 comma 6 here. Now, if we move to this, we can add 10 to this and we got our new subsequence, which is the arithmetic slice. So this is our whole intuition behind this. If we increase the number of array based on number of variable count based on the previous values, we will get the total answer equals to 7. Now we can form a code of this. So our first of all, which data structure should we take to store every value? If we will take an array of maps, I will tell you why. We are taking long to avoid any test cases. So we have taken an vector of maps. Why? Because we have to store the frequency of elements ending at index j. As I told you, we have to keep the frequency of these elements. So at this is the vector and we will store these maps at these vector position. So this similar kind of data structure we will use for our DB. This is our count variable in which we will store our answer. And this is the I counter which I explained you just before this, how we keep on tracking this counter. And this is our J counter which will run till j is less than equal to I, so that we can found all the subsequences ending with I with a given common difference. Now to keep the common difference into account, we will take a difference variable. Now, if we encounter any, this means we will increase this by 1. What this actually signifies? That if there we have increased the count of subsequences which are ending at I with common difference DIFM. So this is well understood. Now, if we have previously find out the same common difference in dp of j, here now we have to add this. I as I explained you already. Now we have to add the number of, like in this example, we have add the dp of ij. We have add these two also from here to this. Now we have also have to add this in the counter. So we can exactly keep the count of all subsequences. Now we can return this code. This code should be running fine now. Yes, it is giving correct answer of test cases. We will submit this. So it is submitted. With time complexity analysis, we will know that this is an n squared solution, and but the constants here are given n equals to 1000, so n squared solution is acceptable. So this is today's code. Thank you everyone and have a nice day.